Here's our final section of Unit 1. This is the law of conservation of mass and energy. So all chemical reactions obey the law of conservation of mass. Matter cannot be created or destroyed during a chemical reaction. It can only change form. So the mass before a reaction has to be totally equal to the total mass after a reaction, which means that the mass of the reactants has to be equal to the total mass of the products. So if you look in this example, we have this calcium chloride solution in this test tube, sodium sulfate solution in this Erlenmeyer flask, and together, well, they're separate right now, and so they have a mass of 300.23 grams. However, if you invert both of them and mix them with each other, a chemical reaction occurs, and now we have a white precipitate at the bottom of this, which is a solid that forms from two liquids. And so after you mix them, you'll see that we have new products and they have the same mass, 300.23 grams. So here we have another chemical reaction. We have a methane molecule plus two separate oxygen molecules, and when these react with each other, they change and rearrange into a carbon dioxide molecule and two water molecules. So the total mass before, this is the reactants on the left side of the arrow, has to be equal to the total mass of the products, which are on the right side of the arrow. So let's consider some numbers. If I had 25 grams of the CH4, methane, 10 total grams of oxygen gas, then my total reactants have a mass of 25 plus 10, which is 35 grams. Yielding my products, let's say I don't know how much carbon dioxide I yielded, but I do know that I yielded 7 grams of water. How much carbon dioxide do we have? So on the left side of this equation, we combine the total reactants to get 35 grams equals, because it has to equal your products, and then I don't know carbon dioxide, call that X, plus my water is 7 grams. Now it's a very simple algebra equation. We're going to subtract 7 from both sides. So we're going to get X is equal to 35 minus 7, and therefore X is equal to 28 grams of carbon dioxide. So notice we can check our answer. 25 and 10 equals 35, and then 28 and 7 is going to be equal to 35 on the right. So we have equal before and after. So in a chemical reaction, although matter may change in form, its mass does not change. So here, your reactants, you would add them together, and then they're going to form a product, and the mass of the product should be equal to the mass of the reactants. So we have, in these two test tubes, 25 grams plus 56 grams. Does that mean we ended up with 88 grams of product? And the answer is, does the reaction above follow the law of conservation of mass? Defend your answer. And the answer is no, because the total mass of my reactants, when you add them together, does not equal this mass of product. So it did not follow the law of conservation of mass. When 150 grams of copper reacts with 40 grams of oxygen gas to form copper oxide, how much copper 2 oxide is produced? So this is what that equation would look like. Copper plus oxygen yields or forms copper 2 oxide. And if I have 150 grams of the copper and it reacts with 40 grams of oxygen, then how much product do I have? I just add the two reactants together, and I get 190 grams of reactant. Therefore, I must have 190 grams of product. Finally, all physical and chemical changes obey the law of conservation of energy. Energy cannot be created or destroyed. Energy can only change forms. A chemical reaction is capable of changing chemical energy into other energy forms. It's usually going to be heat or light. So endothermic versus exothermic processes is what we're focusing on. An endothermic process means that heat is absorbed from the surroundings, and the reaction is going to feel cold. So if you feel a reaction occur and it's cold to the touch, then it's going to be absorbing heat from its surroundings. Your hand is one of those parts of the surroundings, and that's an endothermic process. Baking a cake, boiling water, melting ice, the ice has to absorb heat from the surroundings in order to begin the process of melting. Then there's exothermic. That is when heat is released to the surroundings, which means that it's going to feel hot to the touch. Examples are going to be burning fuel, freezing water, firecrackers exploding, that if you feel heat being given off from a reaction, that's an exothermic reaction.